All right, grade 6. We're actually taking a little bit of a step back here. This is actually grade 5 curriculum, but it's one I find that often grade 5 students have a harder time understanding, and when you get to grade 6, suddenly it's like something clicks, and you tend to understand it a little bit better. So we are going to review it again in grade 6. This is relating area and perimeter. So being able to construct a rectangle that will have a certain area and a certain perimeter. So to start off with, we're going to look at some rectangles. Rectangles with equal perimeters can have different areas. Each rectangle below has a perimeter of 18. So if we look around the outside edge, 2 plus 1, 2, 3, 4, 5, 6, 7, 2 plus 7 is 9, plus another 9 is going to be 18. Okay, yep, that one has a perimeter of 18. Let's take a look at this next one. We have 1 by 6, 7, 8. 1 by 8. 1 and 8 is 9, plus another 9. 9 plus 9 is 18. Yep, this one has a perimeter of 18. Let's check this one. 3 by 1, 2, 3, 4, 5, 6. 3 and 6 is 9, and 3 and 6 is 9, which does mean we have a perimeter of 18. So what you're probably noticing is something plus something has to equal 9, because we know that 9 times 2 is 18, and if we look at our formula here, length plus width times 2 is our perimeter. So we can take the two, divide the two to figure out what our length and width would have to be. So here we've taken 18, we've divided it by 2, which gives us 9, so we know our length and our width have to add to equal 9. Length plus width has to then add to equal that 9. Okay, so that's the key thing here for constructing a rectangle that has a certain perimeter. And you'll notice 1 plus 9, or sorry, 1 plus 8 equals 9. 2 plus 7 equals 9. 3 plus 6 equals 9. What do you want to bet this is? 4 plus 5 equals 9. Ooh, yes it is. So it also would have a perimeter of 18. But as you can see, the area for each one is different. The area here, 8 times 1, is only 8 centimeters squared. The area here, 2 times 7, is 14 centimeters squared. The area here, the shape inside, the space inside, sorry, is 18. 3 times 6 is 18. The area here is 20 centimeters squared. Now, there's a generalization we can make here. The long, skinny rectangle is going to have the smallest area. The rectangle with the least width is going to have the smallest area. The rectangle that is closest to a square, closest to a square is going to have the greatest area. That's a generalization that can be very helpful. If we're looking for a shape that has a small area, we want it to be long and skinny. If we're looking for a shape that has a large area, we want it to be more like a square, or as close to a square as we can get. All right, you are going to do some practice now. Create rectangles that have a given perimeter and then find the area of each rectangle. So you're going to create as many rectangles as possible that have a perimeter of 8 centimeters. Go ahead and press pause and try that now. All right, so we were creating rectangles that have a perimeter of 8 centimeters. So remember, what we did is we realized that our perimeter formula, length plus width, times 2, we're going to do the times 2 part, but we're opposite. So we are dividing by 2. So 8 divided by 2 is 4. So we need something plus something that's going to equal 4. Well, what plus what could equal 4? 1 and 3. So we could have a 1 by 3 shape. Let's check that its perimeter is 8. 1 plus 3 plus 1 plus 3, 4 plus 4. Yep, that equals 8. Check. Okay, what else could equal 8? Or sorry, could equal 4. Something plus something that could equal 4. We could have a 2 by 2 rectangle. Well, actually it would be a square now. That would be 4. Let's double check that it really does have a perimeter of 8. 2 plus 2 plus 2 plus 2. 2, 4, 6, 8. Yep, it has a perimeter of 8. Anything else that can have a perimeter of 8? Well, anything plus anything that can equal 4. Well, 0 plus 4, but we can't have a rectangle with 0 plus 4. And 3 plus 1 we already have. 1 plus 3 isn't going to be any different. So sometimes students will say, okay, well, I can have a rectangle that's 1 by 3, like we have here, but I can also have a rectangle that's 3 by 1. Well, really, that is exactly the same rectangle. All you've done is you've turned it. So this is not two different rectangles. This is one rectangle, just arranged in a different position, but the rectangle is the same. So we can have two rectangles that have a perimeter of 8. Now we're going to have to find out the area of each. So the area of this one, again, area equals length times width. So 1 times 3. What is 1 times 3? It's 3. So the area of this one is 3 centimeters squared, as these are centimeter squares. Let's take a look at this one. Again, area equals length times width. That then means we're going to times 2. Well, what is 2 times 2? 2 times 2 here is 4. So 4 centimeters squared. Let's see if our generalization applies. Our long, skinny rectangle should have the smaller area. Yes, it does. Our more square-like rectangle should have the larger area. Yes, it does. So this is how that generalization can help you. All right, we're going to continue to look at this idea, but with a little slightly different twist. Rectangles with equal areas now, so now we're looking at equal area, can have different perimeters. Note, each rectangle below has an area of 16 centimeters squared. Well, let's confirm that. Area again is length times width. So let's see, our length and our width. Our width is 1. Our length, well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 is 16. Well, 16 times 1 is 16. So, yeah, that has an area of 16. Let's check this next one. 2 by, let's count. 1, 2, 3, 4, 5, 6, 7, 8. Well, 2 by 8. 2 times 8, yep, that equals 16, so it has an area of 16. Let's check our last one. 4 by 4. 4 times 4 is 16, so yes, that has an area of 16. Now they have different perimeters. Let's take a look at those perimeters. So, if we know this is 1 by 16, it's going to have to be 1 plus 16 plus 1 plus 16. Well, that's 17 plus 17. That equals 34. Has a large perimeter. Let's take a look at this one. 2 plus 8 plus 2 plus 8. Well, 2 and 8 is 10. 10 plus 10 is 20 centimeters. So 20 centimeters is our perimeter. Let's take a look at this one. 4 plus 4 plus 4 plus 4, or we could even go 4 times 4, equals a perimeter of 16 centimeters. Now here we can make other generalizations. Now it's careful, you have to be careful not to mix them up. But here we're saying that the rectangle that is the most square has the least perimeter. Now remember, on the last page we also said it had the most area. Okay? The rectangle with the least width, or the one that is the long and skinny, is going to have the greatest perimeter. On the last screen, we also said it's going to have the smallest area. So if we're looking for a rectangle that's going to have a short distance around the outside edge, but the most space inside, we're looking for a square type shape. If we are looking for a rectangle that has a really long distance on the outside, but not taking up a lot of room on the inside, we're looking for a long, skinny rectangle. All right, we're going to do some practice now. Over here, we're going to find some rectangles. We're going to find rectangles that have an area of 24 centimeters squared. Remember, our formula for area equals length times width. So we need to figure out what times what is 24. Go ahead and press pause and try that now. All right, let's take a look. What times what can equal 24? Well, if I know my basic facts, this isn't too tricky. I can use my multiplication table if I need to, or my calculator if that's the case. I can go always 1 times something, so 1 times 24 could equal 24. So I'm going to draw a rectangle that's 1 wide and 24 long. Ooh, let me just count here. Let's see how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I don't have quite enough. So I'm going to have to add some on. Let's move this and add some on. All right, and we're going to add on 3 squares. Assume those are the same size squares, so that would be 1 rectangle. What else times what else could equal 24? Well, 3 times 8 could equal 24. 2 times anything? 2 times 12 could equal 24. 4 times anything? 4 times 6 equals 24. 5 times anything? No. 6 times, well, we already have 6 times 4, so we know we're done. So let's draw those. A 2 by 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oops. I should have done that with my marker. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. 2 by 12 rectangle has an area of 24. 3 by 8 we said. Okay, well 3, 1, 2, 3, 4, 5, 6, 7, 8. So 3 by 8 also has an area of 24. And the last one we said was 4 by 6. 4, 1, 2, 3, 4, 5, 6. All right, now let's figure out which one is going to have the largest perimeter. Well, from our generalization, we shouldn't even have to do any work. We know that our long and skinny rectangle should have the largest perimeter. And from our generalization, we should realize that the smallest rectangle, or the most, not the smallest perimeter, the smallest perimeter rectangle should have the more square-like shape. So this one should have our smallest perimeter. Now let's do some work to confirm that. Okay, if this one was 1 by 24, to find the perimeter, we would have to go 1 plus 24 plus 1 plus 24. So 24 plus 24 is 25, 25 plus 25. That means this has a perimeter of 50 centimeters. Let's check in between here these other ones just to be sure. 2 by 12 by 2 by 12. So 2 plus 12 is 14. 14 plus 14 is 28. So our perimeter for this one is 28. That's definitely smaller. Let's take a look at our next one. 3 by 8. 8 by plus 3 is 11. Another 3 plus 8 is another 11, and 11 and 11 is 22. So 22 centimeters would be our perimeter for that one. And lastly, we had 4 by 6. Well, 4 plus 6 plus 4 plus 6 is 10, which would mean that, yes, in fact, That's 20, and 20 is our smallest perimeter. So our generalization does in fact work. All right, now you get to do some practice, and this practice is going to be on a sheet, not in your textbook, because this is not from your curriculum, but I think you will have a better understanding of it at this point. And of course, needing to know it in grade 5 means you should still know it in grade 6. So we are going to review it. Take a look and answer these questions. Remember to show all your work, okay? Show the length and the width of each rectangle and the work. And the formula would really be good as well. Using 1 centimeter grid paper. If your grid paper isn't 1 centimeter, just use your grid paper anyway, and we're going to assume that each square is 1 centimeter. Something on your page saying that would be good. And make sure you do all the parts. You're drawing all possible rectangles, all of the rectangles that you can find, and then you're finding the area of each of those rectangles. So there shouldn't just be one rectangle for each. There should be many rectangles for each, as many as you can. Second question, I know they're labeled 1 and 2 oppositely. That's okay. Draw all the possible rectangles for this particular area. All of the rectangles for this area, and I need you to find the perimeter of each. Perimeter of each is what you're finding. Perimeter of each afterwards. And again, you should not just have one rectangle for each. There should be many rectangles for each one. So be careful. Do the work properly. If you have questions as you're going, please remember to ask. And of course, you're welcome to use your calculator.